All right, let's get started. Thanks everyone for being here. My name is Balaji Siva, and I have with me Gopinath Rebala. And this talk is about how do you automate some of the industry regulations enforcement during software delivery. So we're going to share with you some ways to do it, and also some sample policies, and also a mechanism to help you automate as many of the enforcements for industry regulation in software delivery through this talk. And if you have any questions, feel free to obviously ask us in the end of this session. So before we start, I want to give you a little introduction about the topic and what the motivations are, what some of the challenges are, and then Gopi would talk about how to go about it, and then I'll have some demos at the end. So this talk is about some of the industry regulations. I think you probably, if you're running any public company or even private companies, you're probably familiar with many of them. That the software industry, you're essentially have to be part of that. Your company has to be able to accept these or to be able to comply with these regulations. So software teams have to be part of that. So some of the well-known ones are things like SOC 2, which is obviously anytime you collect customer data, there's a way to how do you handle customer data. When you're a SaaS company or your website collecting data, then you have certain rules and regulations that you have to follow for that process. And obviously, if you're collecting credit cards, then you have to obviously comply with the PCI. If you're if you're doing any public company, you're probably familiar with SOX compliance. There's a lot of regulations around how do you do financial reporting, but obviously software team also is impacted by these regulations. Obviously, the ISO 27001 is obviously very popular and pretty common for any industries. Both, we at OpsMx, we just recently went through these SOC 2 compliance ourselves, and as well as the ISO 27001. So there's a lot of things that's besides what's covered in this presentation, but you're going to see some commonalities between all of these things. GDPR obviously is the EU law to prevent the data protection and privacy for the customer data that you're collecting. And there's obviously a lot of things, a lot of compliance around FedRamp and federal, like FISMA and FedRamp. And these things have to also, if you're developing software or your customers, end customers are actually federal customers, then you have to comply with. And some of the things that we're going to talk about today is how do you, as an end user or as a vendor or provider of services to other companies, you have to enable these controls and compliance checks as part of your software delivery. So to give you a couple of this in SOC 2, primarily breaks down this. You see these pillars here. This is typically kind of repeating across all of these compliance frameworks, right? So meaning if you're SOC 2 compliant, you're probably partially compliant on other compliance as well. Like I think one statistic I read was if you're NIST compliant, you're probably 80% compliant to ISO 27001 or something like that. So there's always a overlap of what you have to enable and process and controls, and they are very similar across these things. There are some variants, obviously, that you have to adhere. And obviously, you have an auditing process, so the auditors for that compliance are going to ask you specific things. So that's true. But if you enable many of these things as a general practice, you're probably more closer to getting compliance certification. So security is obviously protecting the information for unauthorized access, obviously the disclosure of information, everything that you think about security perspective. Particularly for SOC 2, that is the only criteria that you need to comply with to get the certification. The rest of them is basically is not part of the compliance requirement. But it is something you would probably do anyway, like availability, make sure that systems are available. Integrity obviously is needed for a lot of other compliance regulations. Like how do you make sure the processing is complete, valid, accurate, timely, and authorized. Confidentiality, almost every compliance requirement requires that, and also privacy of data. If you look at SOX compliance, very quickly, obviously this is purely from a regular financial reporting perspective, But from a software team perspective, one of the requirements I've seen is that obviously separation of duty, right? People who are creating or making changes to the software cannot be the approvers of things to the production also. To obviously to prevent some malicious actor being able to, push incorrect data or incorrect software to the production systems. So what are the drivers for automation of these compliance checking, right? So the current process I've seen in one of the large customers that we work with, they really create a ticket and then it goes to a ticketing system, and then there's a compliance team that checks that, the compliance of the software before they approve or reject it. Sometimes they do it on Friday. That means nobody's checking it for till Monday morning. So there's a lot of basically time lost. If you're trying to do continuous delivery, it makes it very hard. And obviously, the DevOps model, the developers are pushing code to production in some ways, right? They're self-service as well. So you want to make it easy for developers to be able to comply to all the regulations. You don't want to make it that another team is going to look at it ad hoc, right? You want to be part of the delivery workflow, and that's something is very important, particularly when the frequency of deployment is increasing. There's no way to do it ad hoc like we are doing right now, which is creating a ticket outside the process and waiting for somebody to do something. And also, in order for us to scale, you want to make it the compliance policies and security policies, has to be version control, best practice, widely available for the enterprise. If you make a change somewhere, it's also available quickly across every software deployment that's happening. So that's very important. And the last but not the least is basically the auditing part that has to also be part of this compliance automation. Because without auditability or evidence collection, you're not going to be able to get compliance from your auditors. So that's pretty important. So what are some of the other complexities? If you look at a CI/CD pipeline, from core to production, basically, you have to secure the delivery process. So some of the things around is obviously the role-based access control in terms of who can access the system itself, as well as granularly at the application level, who can access a specific application, and also specific approvals and stages and those kind of things. That's also very important. So the granular level, the role-based access control has to be at a fine-grained level, not just an application level or pipeline level, here at a stage level, and many things. You have to enforce these also in a policy model, so that, and you have to set up guardrails. People will make mistakes, right? Some may not be harmful or intentional, but they will make mistakes. So you need to make sure that you set up the guardrails. The other piece that we struggle with in our company, and I'm sure you've heard of other companies, is how do you maintain the keys? We get a notification from AWS that your keys are public every other day, right? And so we got to make sure that those things are not happening. So again, that also needs to be the ability to secrets of the infrastructure that you're deploying to, as well as secrets that you use for your software itself. Those has to be maintained at scale. And we talked about the DevOps approval process. Essentially, that's another challenge that we need to address. Is essentially it has to be part of the system, not outside. Evidence collection, and these are called what I'm calling it the process, right? This is something that you have to enable, and then application security. You're already familiar with the existing tools like SonarQube or other scanning tools, security scanning tools, SAST, DAST tools, and those has to be integrated as part of the process, so that your results are available in line, and if a pipeline needs to be stopped, then you're able to stop that right there. Or people are making approvals, they have all the information available to make the right calls. And also you have to look at application risks also in an automated fashion. So what I mean by that is you are releasing a new software, you can't expose new ports, for example, or you can't deploy for GDPR compliance, for example, maybe deploy in another region that you're not supposed to. So those things has to be integrated as part of the compliance automation. And last part is obviously you have to be able to do it at scale, right? So this is the part where it's maybe easy to do it at slow pace, but if you have to do it at scale, if there is a vulnerability on one application, then you want to quickly figure out the supply chain information and to figure out what are the applications that are running in the production that are affected by these things. So we work as OpsMx, we obviously do it for ourselves, but also we work with a lot of other clients, large companies, and so we have had a lot of expertise in trying to help it. And I would like to turn it over to Gopi, who's going to walk us through how we have seen it done, and we have done as well, and take it from there.
Thank you, Balaji. You guys can hear me okay? Thank you. So we went through what is the complexity in automating these compliance requirements, right? Part of the problem comes because of the speed of the delivery requirements and the changes that are being done. We also want to have developers be responsible for some of their application delivery, but at the same time, we want compliance to be applied centrally as an organization requires. Now, the question is, these compliances have many aspects to it. Some of them define physical security, virtual security, processes, and all of it. But we are mostly focused on the continuous delivery, but even then, a couple of questions. How do you map these requirements into requirements for the continuous delivery? And the second one is, how do you automate these parts of it without having to be a one-time implementation, hard to change, and be a continuous living thing? So just to give a high-level view on most of these compliances, standards, follow these kind of confidentiality, availability, and integrity rules, CIA rules. So these define guidelines in most cases. In some of the cases where, like FedRamp, they get a little bit more prescriptive. But essentially what they are trying to do is, in the confidentiality, the separation of duties are back, and making sure the data is secure, both in rest and in transit. Those kind of definitions will be there. In terms of integrity, you have the integrity of the data. Whoever can modify the data only should be able to modify the data and should not be available for the rest of the groups or people. And you want to be able to provide the traceability of the artifacts. So you deploy something in production, you want to be able to trace who changed it, who approved it, and what was tested on it, et cetera, all of these. So these are the ones, I'm just highlighting a couple of those. Availability is more in terms of making sure the system is available. You have best practices for DDoS attacks, hindrance, those kind of things we need to make sure. So these are the core issues that you can automate as part of your process, right? Now, if you look at what does it involve in automating these? So we have multiple actors in an organization. So the developers are responsible for a few things like code scans, code reviews, and things like that. And then you may have a performance analysis departments that are looking at QA, validation, performance analysis of those. And then you have SecOps that's focused on what is your compliance requirement, specification of those, and approving the architecture that is required for the deployment and things like that. And the operations want to make sure the changes that are going in is not going to break their production, or anything that changes needs to be rolled back. No changes happen to, say, firewall rules. Some of these we will see in the demo later. So the complexity here is the handover process and also specification of these requirements by the enterprise and making sure these are followed, right? So there is always some friction between development groups trying to move faster and the SecOps wanting to make sure this is secure, and how do they interact is one of the issues. So the that we use here essentially has a policies defined as code on one side, and then the data that comes from different sources in your delivery process on the one side. So the core idea here is that the policy specification needs to be shared, documented, version controlled, that can be directly applied onto your data. We use the open policy agent for these policies. And one of the things that you can see, the three things I would like to highlight, right? So the separation of these policies from the data. The second one is being able to specify your process itself as code, or something like a pipeline as code. our underlying delivery platform is Spinnaker. In Spinnaker, we have a pipeline specification that can be stored in Git, version control. It has certain number of steps that you specify. But one of the core requirements there is these steps are like a metadata. You want to be able to specify the steps separate from actual execution of it. For example, you have a requirement to say dynamic code analysis, or you require a canary analysis before going into the production. You want to be able to specify these steps are required as a policy document, and as the pipeline specification pipeline executes, depending on the target environment, let's say it's going to production, then you enforce saying the pipeline process definition itself to include the canary analysis. So these are like guardrails when the developers are developing these pipelines for their delivery. You ensure and give them the guidelines saying these needs to be there. So essentially, these policies controlled by central department, but the actual pipelines are created, executed by the DevOps groups. That's one. The second one is this audit database. So all of this data that's generated by different tools in an organization, there are so many DevOps tools, right? Everyone has slight variations of those. You want to be able to collect this metadata for these tools centrally, so then you can apply these policies on it. Not only that, you want to be able to have the observability. So the way one of the simple use cases that we use here is the immutable artifact. In Spinnaker, containers with the SHA or even the AMIs, those are immutable that we test and then deploy to production. We use the same AMIs. So you have those SHAs by simply tracking the SHAs, by having the metadata coming from the code scans, dynamic analysis, or vulnerability scans. We have ability to point to whichever scans that were done and their results. So now you can have a policy document that specifies a minimum requirement for your CVEs, for example. If they don't match those CVE requirements, then you stop the admission to the production. Okay. So very simple structure, but very powerful in allowing the self-service, the centrally defining these policies, and the developers have the ability to create their own pipelines that are conform to these policies. So one of the things that you may notice is this ML analysis here on the right-hand side is one of the data principles. Typically, you may think that machine learning analysis would generate the risk, and you basically control deployments based on the ML analysis. But the way our customers mostly have started using it is you use the ML analysis for the risk analysis. So there's a certain score, but then use that score as a policy document that says if it's above the score, automatically allow it to deploy to production, but if it's below, then they go through a manual process. So there's a two-step process even with ML. Today we do mostly at the canary analysis or the blue-green analysis at the time of deployment. In future, we expect that to expand across multiple data sources to give a better risk analysis on it. And to give a more visual view on how this is actually done in practice, if we have a pipeline that's defined, so each of these stages are, say, stages of the pipeline. So this is a simplified version. There will be multiple things that will be going on, and this could be 2 or 3 different pipelines. So one is going to QA, one is going to operations. It doesn't matter, right? Because we are now able to collect the data from each of these stages into a metadata store, providing the guardrails, allowing them to have these stages in place. So if a pipeline removes the dynamic analysis and the policy document says it requires it, then they won't be able to remove it. In fact, they won't be able to save that pipeline document for their execution. And then at the time of the production, deploying to production, you can do a admission control kind of a check. That simply check would be applying the data from the metadata store for that artifact that we are deploying to the policy engine. And if it says yes, you go forward. If it says no, you have the list of policies that have violated or not been executed. So you would stop, and then it's very easy to go back and correct those things. Right? Now, because we are able to create these policy documents just for the process itself, as well as individual stores, we are able to share this between the developers and security groups and operations very easily and change for them. So now we will see some of demos for a couple of these processes. Let me hand it over to Balaji.
Thanks, Gopi. So very quickly, I mean, obviously, you want to be able to have compliance as code, obviously, for a lot of reasons we talked about. It's easy to codify. It's easy to do handover between teams. Everybody knows exactly what is actually getting checked. You can obviously store the results and the data in an auditable format so that the auditors are able to look at the data, and you can do it at scale, essentially. And so that's sort of the idea of this. Here are some of the examples of compliance as code that some of our users have created. Some of them for SOX compliance, but there could be a lot of other things that one can enable throughout the overall pipeline. If you think about it, there are multiple players in the pipeline, as Gopi pointed out, and everybody needs something else. And some of them are compliance related, and some of them might not be compliance related, but many of them are compliance related if you think about it. And so these are some of the examples of pipelines, things, policies that people have enabled. So in the demo that I'm going to show you, we are using Spinnaker, and we're using OPA as a policy server for checking the compliance. We have collecting data sources. Obviously, the data itself, multiple data sources are getting collected and stored in a data store, like Gopi was pointing out. That's pretty important because you want to be able to have policies not only on, let's say, the Spinnaker or execution orchestration. Think of Spinnaker as an orchestration platform for this use case, right? Meaning you could have something else, you can have different things, but OPA essentially is collecting the OPA will basically be the enforcer, but there's a data collection, data lake, essentially. You have to collect the data and store in a data lake. And Spinnaker will be the orchestration layer that will trigger these enforcement points. So is it allowed or not allowed, right? So OPA is the one who's making the decisions. And once all of the decisions are done or it's happening, you're also storing it in audit, right? Not you're storing all the events from all the data sources, but also storing the results of these compliance checks. So essentially, then you would be able to satisfy an auditor. So let's take a quick example here. One is around SOX compliance, which is basically a separation of duty. I think this is one of the common use cases that we have, but that few things. One is the person who is triggering the pipeline or triggering the code check-in, for example, should not be the one who is approving the artifact to production, right, or somebody else, or to the next stage. You want to make sure that there's a separation of duty so that there's two people who's doing it, and you can control that through a policy. And or you can have, let's say you have two approvals, maybe an approval from QA to staging and another approval from staging to production. You want to make sure that the approver that is doing the QA to staging is not the same approver for doing from staging to production. And there's another approval separation of duty. All the examples I'm showing you and many more are stored essentially in this GitHub folder that you can sort of look at. And obviously, we will keep on updating many of those use cases. So that the demo itself, I'm going to show you, it's called the policy demo. Let me just make sure it loads up here. Okay, so there's these pipelines here. So the first demo basically is about separation of duty. So if you look at the pipeline, essentially there's a build, there's a deploy to test, and there's approval production. So we are doing a separation of duty check here to ensure that somebody who triggered this build process is not the same one who's going to approve to production. And so we will create this execution right now. It'll take a minute to execute. And in the meantime, what I will do is I'll show you the next demo that I'm going to tee up, and then you will see that also. So the next demo is basically, the next we talked about is two approvals. One is the approvals here. This particular pipeline actually has two approvals, verified to QA or verified to staging, approved to staging, and then approved to production. So here we will show you that you can't have the same approver approving it twice. Let's execute that first. So here it's going to go to an approval. And this policy code we just saw already in the slide. This is an approval. So I'm the approver here. I'm going to approve right now. So the next, it's going to go to the approval to production. Now, since I'm the same approver, if I'm going to approve it, I have access to the approval, or I have the authorized approval. But just because I approved the first one, I can't be the same person approving it. So if I try to approve it again, what will happen is there's a policy check, and it's going to check really quick and give you a result and say, okay, there you go, you reject it. Right? This is an example of ability to do separation of duty check as part of the pipeline. So if there's another stage, typically it would be a production deployment. If it was different approvers, then it will obviously go to the production deployment. Let's go back to the previous one, the example where I triggered the pipeline, and that means I am the starter of the pipeline. I should not be also the approver of the pipeline. So separation of duty. Again, another check here. I'm going to try to continue here, which you should fail. There you go. It failed immediately because I created the pipeline also. Another example I want to show you is how do you do process integrity check, right? This is something very important to make sure that when you're doing compliance checks, if you have certain process in place and you don't want your developers to circumvent that process. For example, this is a SOC 2 requirement where I have a requirement in this case to be able to have deployment to production go through an approval process. So I don't want to have deployments going straight to an approval. This deployment is actually an approval. It's deploying to a Kubernetes cluster, as you can see here. I don't want that deployment to this cluster, for example, go straight without an approval, right? So I have this approval stage. So let's say I'm trying to be sneaky and I'm going to try to remove the approval. So approval, let's say, is going to my boss, and I don't want that person to see that I'm actually deploying. And so I'm going to try to remove this stage, for example. And this is essentially, I'm trying to circumvent the process, right? The process integrity is lost now. If I try to save this, see, I have a policy, even though there's no policy stage, but it's always running to ensure that there's a policy. You can't remove manual judgment state. This is very useful. Now I can't save it, so I have to really go out of it because there's no way to save this pipeline because I try to commit a policy violation. And the last but not the least, again, you can set up a lot of things. You can set up things like I can have a policy which we can only go to QA if we go to production only if all the QA tickets are closed, high priority is closed. So many different ways you can define policies. But what we're saying here is that you want to make sure that you have the ability, you could control things and set up the required regulatory policies as part of the pipeline. That's sort of our ask here to you guys. The other thing is I'm going to check the compliance check. For example, an application is getting deployed here, and an application is getting deployed. I want to make sure that we are able to check this thing. So I'm scanning the deployed, let's say you're deploying to staging, and I want to make sure that the deployed artifact, the developer didn't change any new security ports, for example. So here, this is just going to display the security port, display the config, display the scanned staging security groups in AWS, and then we're going to have a check to make sure that new ports are not open. In this case, we're trying to say that port 22 should not be open for whatever reason. So we're going to say, you go deploy to staging, I'm going to scan you, and then basically, we have a policy that basically essentially confirms that you have ports enabled, open ports enabled, and we're going to stop that deployment going forward. Right, so it's now scanning the security groups. It'll take a minute. Let's see. So again, all of these policies and more of them are available on this website, so you can go download it and please feel free to do a pull request if you have some that you want to contribute. And so there you go. It went through it. It pulled the deployed artifact, and here's basically what we found out from the security group. The port 22 is open, so our policy basically was there was to make sure that it's not happening, right? So this is what we recommend as what you should be doing to really get automating the compliance. So that's our sort of recommendation here. You want to automate regulation during software delivery. Make sure you have all the checks, security checks and tools as part of a pipeline, so there's nothing ad hoc going on. This is very important so that you get the data and you use it for traceability and auditability of your delivery. And you also want to make sure that if there are processes and things that you want to enable, and do it as a policy so that you have available to audit it as well as automate the policy. And you have admission control checks, obviously, to make sure that you have it. The policies are available on this GitHub, so feel free to use it. If you have suggestions, feel free to suggest a pull request or issue on it. And also, if you want to use the demo that we just showed you, you can go download the community edition of our, what we call an Autopilot, which is basically an automated way to do CD validation, checks, and audit, etc., etc. So it's available as a free download. It's primarily for Spinnaker today, but we're also adding support for Argo in the near future. So you can actually get this working for both Argo and Spinnaker. And you can obviously reach out to us if you have more information, if you need more information. Any questions we can take, or we're also available in after the call, after the presentation. All right, we'll be down here. If you have any questions, feel free to reach out to us. Thank you.
One question maybe.
Yeah, go ahead.
Answer that partly already. What are the prerequisites to use such a solution? So you need to collect data and you need to enforce the solution. So,
yeah, so
which
the
combination of tools your solution works?
yeah, so first of all, you need to be able to, so we recommend something like a Spinnaker, for example, to be able to automate the workflow in the first place, right? So you have end-to-end automation, everything is scored, like pipeline is scored and those kind of things. That's very important to do that. Second part is you're integrating all these tools, like, your build tools, your scanning tools, and other tools. And you want to be able to collect the data that's part of that particular pipeline. Let's say you take a code check-in. You want to be able to really trace the code check-in to a build, to the results of the build from scanning tools and other tools, and then the deployments, that the immediate data, the ports that are open. You want to be able to track all of them. So you want to collect all the ingested information in a data lake. Now you have the data from the CD tool, and you have obviously the data from all the tools in a data lake. Then you can create these enforcement policies through an OPA. So you have to feed the OPA through the Lego. You have to feed the OPA server the data and your policy, then you can do it. So I would suggest Spinnaker, OPA. Obviously, the data lake piece, obviously you may have to build it if you don't have it, because that's essentially is the crux there. And also you want to do audit. So you want to take all the events from all the tools and be able to put an audit database. Obviously, we have done it, obviously, in the tool that we just showed you. You can download that free tool and it should work for you for free forever. So you can use that tool, and if you need enterprise support, obviously we are here. All right, any other questions? Okay, great. Thank you very much, guys.